So to estimate this numerically, we have a couple of options. We could look at a graph of it, and we can play around with a table of values. So I think I'll do a little bit of both on that. You need to give the answer to at least 3 decimal places. So your version may be slightly different. X is going to 0. Now it doesn't say whether I'm the left or the right, so I need to look at both. So this is 2 different problems. We need to look at the limit, oops, as X approaches 0 from the left side, for 9x minus 1 over x, and we need to look at the limit as x approaches 0 on the right side of 9 to the x minus 1 over x. And if I try to cheat and plug in 0, 9 to the 0 is 1, 1 minus 1 is 0 over 0. So if I cheat here, I get 0 over 0, which is indeterminate. Meaning there may be an answer. There may be numerical value here. And we may be able to say something like it's 2 or 4 or pi, but it may be a number we don't recognize. So let's ask our graphing calculator, reset please. So I'm going to call this f of x because function notation is useful. And it's a fraction, 9 raised to the x, then minus 1, then divide by x. And I can see at 0, something seems to be happening there. But if I try to actually plug in 0, it says undefined. If I can touch it, there we go, undefined. So I already knew that from my notebook. F of 0 does not exist. It is undefined. However, the function seems to be doing something nice there. If I zoom in, it seems to have an answer somewhere between 2 and 2.5. Mine looks like maybe 2.2-ish. And so to check that, we're just going to approach 0 from each side. So f of 0.01, perhaps, and then f of 0.0001. And it looks like it's a little under 2.2. F of 0.00001. Okay, so I'm getting a number a little bit under, and these two agree to 3 decimal places on what that value is. 2.197 on my version. Should double check the other side. Now, so far I just looked on the right side, but it looks like the left side is heading to the same place, right? But it's always good to double check. So I'm just going to do the negative version of that last one. And I can see, yeah, 3 decimal places, 2.197. So I got 3 decimal places. Could it be 2.1972? I would have to keep exploring if I wanted to get more decimal places. And at some point, the calculator is going to lose track of decimals, and I'm going to get weird answers here, or it's just going to say I can't do it anymore. So keep in mind, on some calculators, if you try to plug in too small or too big a number, it cannot keep track of all of those digits for you. So you'll get some weird stuff. So let's see, if I put a whole bunch more zeros in here, at some point, it's going to probably go wackadoodle on me. Oh, yeah, now it's jumping all over the place. It's going, oh, and now it says it's 0, right? So again, cannot compute. These tools cannot do anything for us. There's a limited amount of things they're programming to do, and keeping track of that many digits is computationally hard. And if you're going into programming, you will learn about that. So on mine right here, I think mine was about 2.197 to 3 decimal places. Am I lying? Is that the truth? That's the truth to the best of my ability at the moment. And even in a spreadsheet, if I tried to go out more places, the spreadsheet eventually would lose track. And so if somebody said, give me the answer to 10 decimal places, I don't think Desmos is capable of making that computation. But there are other packages, software packages that can.